Hi everybody, I'm Greg, and this here Zorro looking character is my sidekick Sparky. Isn't it interesting how Zorro used to have a sidekick and now he is one? Didn't he have a sidekick horse or something like that named Trigger? I don't know. He's what, a Mexican or American hero? And I'm here in Canada. And here in Canada, we don't have heroes with sidekick horses. We have Sasquatch. Right now, somebody somewhere is going, "What? Y'all got Bigfoot as a pet in Canada?" No, we don't. They're way too stinky. And that hair, oh, it sheds and it's terrible to clean up. You also can't keep maple syrup around. They drink it like it's a drug. Yeah. And in Canada, there's a law that says if you have a Sasquatch as a pet, the exterior doors to your house have to be at least 4.5 feet wide and 10.5 feet tall in case there's an emergency. That way he can get out without hurting himself or destroying the house. Yeah, because let's face it, if there's a fire, he's just going to go up like that with all that hair. Yeah, he'd be like a running torch. So, yeah. If you ever have the opportunity to have a Sasquatch as a pet, don't do it. I don't recommend it. So welcome to Muscle Essentials, lesson number 3. Lesson number 3 is all about connective tissue. On the website, greglenko.com, you can find it under the menu Muscle Essentials, submenu Muscle and Other Tissue, I believe it is, or Muscle and Connective Tissue, something like that. You'll find it. It's easy to find. Before we get into lesson number 3, though, we're going to do a quick review of lesson number 2. Lesson number 2 was directional terms, and there were 13 of them. They were superior, inferior, medial, lateral, ipsilateral, contralateral, deep, intermediate, superficial, posterior, anterior, distal, and proximal. So for this lesson, I'm basically going to be reading verbatim. I wrote the notes down myself, printed the notes off myself. I'll just be reading those verbatim, plus some other examples we're using. Feel free to follow along or print them out. It's going to be about a 20-minute lesson, so hopefully you have 20 minutes to watch this right now. If not, you can always come back to it later. Let me think, what else should I tell you about today's lesson? Connective tissue. It's going to give you a really good understanding of how connective tissue interacts with each other, specifically muscles. So let's get started. Connective tissue. What is it? Connective tissue is simply a term used to describe the various cells in your body, also known as a cellular matrix, that make up all the different structures in our bodies. It's the most abundant and widely distributed type of tissue in our body, so it's basically everywhere, and it has a whole bunch of functions and stuff like that. It has, what does it do? It binds, supports, and strengthens other body tissues. It compartmentalizes the different structures in our body, and it's also the primary location for stored energy. We're going to be going over this stuff. There's also 2 basic elements of connective tissue. There is the extracellular matrix and cells, and that cellular matrix is made up of ground substance, water, and protein fibers. That's why people who work out a lot, like bodybuilders and stuff like that, are always like, yeah, drink lots of water and eat lots of protein so you can build those muscles. You can look at my connective tissue. Do you like my connective tissue? Feel it. So, I get a little carried away. So let's talk about the different types of connective tissue. There are several types. There is loose connective tissue, dense connective tissue, there's cartilage, actually it's right here behind me, there's also bone and liquid. And in each of these categories, there are subcategories, and let's review those real quick. When I'm going over the subcategories, I'm going to talk about where you'll find this connective tissue. These aren't the only places you're going to find the connective tissue, but they're going to be the most, I don't want to say most common, but the ones that might be most familiar to you. So for loose connective tissue, the subcategories are areolar connective tissue, adipose tissue, and reticular connective tissue. And areolar connective tissue is found in different layers of skin, around blood vessels, nerves, and organs. Adipose tissue, it's fat. all right? And it's also found around organs, padding around your joints, also behind your eyeball in the eye socket, it's found there too. And that's kind of cool. There's also reticular connective tissue, which is found in the supporting framework, also known as stroma, new word, okay? Stroma, the supporting framework of the liver, spleen, lymph nodes, and around blood vessels and muscles. And that's loose connective tissue. For dense connective tissue, there's dense regular connective tissue. Therefore, there's also dense irregular connective tissue, and there's elastic tissue. For dense regular connective tissue, it forms tendons, most ligaments, fascia, or aponeurosis. Okay, new word for you, aponeurosis. Okay, not apple, apo. Let me think. The most familiar one, at least the one you might be familiar with, is called the bicipital aponeurosis. So an aponeurosis is a sheet-like tendon. Okay, so you have your tendons, the proximal tendons that attach up here. You also have a distal tendon that attaches right here to this little thing that sticks out of the bone. This is your radius. Okay, this would be the radius. And this here thing that sticks out is the radial tuberosity. And the distal tendon, the distal insertion is the tendon attaching there. But it also forms the bicipital aponeurosis, which is that flat tendon-like sheet that wraps medially around the forearm into the deep fascia of the forearm. And I'm going to give you an example. I'll show you an example of it now. In the Atlas of Human Anatomy, 4th edition by Frank Netter. Just going to move my vertebrae out of the way. Glass tabletop. Bicipital aponeurosis. All right. So here is the bicep. All right. The proximal insertions up here, the tendons up there. Distal tendon down here, which attaches to that radial tuberosity. But you see this white stuff here? That flat sheet of stuff, that's the bicipital aponeurosis that wraps medially around the forearm into that deep fascia. And we'll get into fascia in a bit too to give you a better understanding of that. So there's also dense irregular connective tissue, which is found in fascia beneath the skin, around muscles and other organs, including the pericardium of the heart and the periosteum of bone. Remember that, periosteum of bone. That's aponeurosis there. And lastly, there is elastic connective tissue, which is found in lung tissue, walls of elastic arteries, and your vocal cords. I just had a flashback of the Flintstones. Would the real Fred Flintstone please identify himself? After 40 years, I finally figured out how they made that voice. Okay, so that is dense connective tissue. Now there is cartilage. 3 types of cartilage, 3 categories: hyaline cartilage, fibrocartilage, and elastic cartilage. Hyaline cartilage is found at the ends of long bones, your nose, and parts of your larynx. Fibrocartilage is found in your intervertebral discs, the menisci of your knee, and a thing called your pubic symphysis. So, if you're not sure what your pubic symphysis is, I'll show you on Sparky here. All right, Sparks, get ready, going up. All right, watch your head. Okay, your pubic symphysis. So, right here, just above your private area, you have a couple of these bony prominences. When you press on them, they're like sharp and they hurt, okay? Those are called your pubic tubercles. If you go from those, move medially toward the center line of your body, there's a piece of cartilage there. That is the pubic symphysis right there. All right, coming down. Here we go. Oh, you grabbed my shirt. Hold on, give it back. Trying to unzip my jacket. Huh. All of a sudden you are the Frenchman, eh? With the beret. All right, whatever. What are you, Mexican, French, or American? Can't figure it out. All right. Now there's fibrocartilage. No, we just did fibrocartilage. Elastic cartilage, which is found in part of your external ear and on your larynx. Bone tissue. Compact bone is the submenu, and that's found in bone. And lastly, liquid connective tissue, blood, which is found, within blood vessels, blah, 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 et cetera, et cetera. All right, so that's connective tissue. Now let's get into some muscles, shall we? We're going to focus mainly on skeletal muscle, but I do want to touch on a couple of other types of muscle, okay? So first of all, skeletal muscle, what is it? Well, it is the voluntary contractile tissue that moves your skeleton. That's basically it. The most important two things there is that it's voluntary, so you contract it voluntarily, you think about it, and it moves your skeleton. It's also striated. That's kind of important too. So it's striated like a piece of wood. All right, you can see how the striations going up and down. Okay, you can see the striations in muscle as well. Whereas smooth muscle is not striated, which is why it's called smooth. And it's also contracted involuntary, meaning you don't think about it. And it's found in your intestines, in your GI tract. Okay, so basically you chew your food, you swallow your food, and then you don't think about it. Your body just does what it does involuntarily, okay? And lastly, there is cardiac muscle. Cardiac muscle is actually a combination of both striated and smooth, and it's also involuntary, meaning you don't sit here and think about, contracting your heart muscle, pumping blood through, right? You don't sit here and go, pump, 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 or stop your heart. Unless, of course, you took some ancient martial arts course. Okay, so on the website, let's get into the skeletal muscle. On my website, greglenko.com, I compared skeletal muscle. I compared our bodies basically to a piece, or not a piece, to a tropical fruit. I think it was a lemon or a lime. And I happen to have some fruit with me, so I'm just going to get that, be right back, and going to show you right here how it compares to fruit, okay? Okay, I'm back, and I have with me a lovely grapefruit. And I'm going to show you how our bodies are a lot like a grapefruit or a tropical fruit. Like I said on the website, it was a lemon or a lime. So I'm just going to peel this. Oh, I love grapefruit, but that was, oh. So just like a grapefruit, we are covered in skin. And when I peel the skin off, we have 3 layers though. This has skin and rind. Okay, you might want to come back in a second. Just go have a drink. Have a bite to eat. All right, here we go. So, well, you don't see it very well here because of the rind. Okay, so underneath this rind is a layer of what I'll call fascia, which our bodies are surrounded with. Okay, and so are our groups of muscles. So there it is here. So you can see that there. Okay, that's kind of fascia-ish. So if we peel this apart, there you go. Well, didn't peel the way I hoped it would, but good enough. So we're peeling this apart. Here we go. That'll do it. Okay, these wedges are like muscles, individual muscles. So you have the fascia around the whole thing, then you got fascia around the individual muscles, and that would be this here. And then inside the individual muscles, you have these little, okay, so this is grapefruit, has these little buds, and our muscles has muscle fibers. See, and they're being held together by fascia. You can actually even see that in there, right? See that? So that's how our bodies are a lot like a tropical fruit. And whereas we have a tendon on each side of the muscle, this just has what I'll call a tendon, not really, but sort of, which hangs from the branch, right? The stem. So that is, that's how we compare to a tropical fruit. Now, if you look behind me here, I have a diagram of basically, yes, that is a bone, tendon, and muscle. And I'll show you how it works here with the different types of fascia. There's 3 types of fascia. There's epimysium, paramysium, and endomysium, and they're easy to remember. Epimysium is the first layer. All you have to do is remember E, P, and E. Epimysium is the first layer. The second letter of the word epimysium is a P, and the first letter of the second layer starts with a P, paramysium. And the last letter, it starts with an E again, but it's E-N-D, endomysium. Endo meaning last layer, the deepest layer. So epimysium, paramysium, epimysium. So we have our bone, a tendon, epimysium surrounding the belly of the muscle. Now this muscle is made up of muscle fibers, and a group of 10 or more muscle fibers is called a fascicle. So these, surrounded in blue, are fascicles. That blue is the paramysium surrounding the fascicles. Now a fascicle, one fascicle is a group of 10 or more muscle cells or muscle fibers. This muscle cell and fiber is the same thing. So this would be a muscle fiber. Here. So this is the fascicle. I moved it over here. It'll be easier to see on this one here. So one fascicle and the individual muscle fibers inside. So that's like 10 or more. Now these individual muscle fibers are surrounded by the endomysium. So I'll show you again real quick. Bone, tendon, epimysium around the belly of the muscle. The muscle is made up of fascicles surrounded by paramysium. The fascicle is made up of muscle cells surrounded by endomysium. And that's the basics of a muscle. Now I also have some more show and tell for you. I brought a turkey leg so you can see how it is in a creature, how it compares to, because I can't use a human. So we'll see how it all comes together in an animal. I'll be right back. Okay, so here we are with a turkey leg. Let me show you how this works now. So we have a nice big leg there, right? Like a king. Just give me my throne. So we have the skin, which is kind of stuck. You can see that it's stuck a little bit, right? You can see it pulling here on this fascia. Can you see the fascia? That's fat. There's the fascia there. See that? The fascial tissue. Okay, the skin is stuck to that. So we pull it off. And you can even see, I'm getting excited here. You can even see how, like, the individual muscles. Okay, so you have this here, and you have another muscle here, and you have another one here. And it's all being separated by fascia. And that fascia is tough. And again, like I said, it will stick to. And this is the reason, actually, there, I ripped some of the fascia. I do not eat meat off a bone because I know what it is, and it's kind of got, yeah, I'm not enjoying it over the years, put it that way. Okay, so you can see this here. You can I don't know if you can see it because of the glare. If I bring it a little closer, you can see the striations in this muscle this way. Can you see the striations? Possibly? Okay. And you can see this white stuff here, which could be, and probably is, more fascia. Okay, now I'm pulling this apart, and you can see it's pulling along the separation there. All right, some meat, which had Sasquatch, can feed them. I'm just gonna try to squeeze this through. See, there's some more fascia there. I'm getting blood on me, of course, coming out of the bone. Blood vessels. See what we got there. Okay, look at that. There we go. Look, this is gonna be really good. This is tough. Okay, now the tough part of this is the tendon. Look at that. See that tendon? Oh, right here. That's a tough tendon. Like, I'm trying to pull it and it doesn't want to pull. And you can see the fascia around the tendon even. You see that? Right there? Like, that's a tendon, and there it is. Now it slides out. There. See that? That's tendon right here. And it sort of peeled off too. Here it is again. Oh, this is a big tendon. There's a couple of them here. See that? There's a tendon there. So there's a few muscles in here. I don't know the, unfortunately, I don't know the, and you know what, I don't know the anatomy of a turkey, but hear that? Hear the tendon? kind of interesting. So there's a lot of little muscles in a turkey drumstick apparently. More tendon. So I'm not sure if you know what an avulsion fracture is. So an avulsion fracture is when the tendon pulls some of the periosteum or all of the periosteum out of a bone. So a tendon attaches a muscle to the periosteum of the bone. The periosteum is not bone, but it's on the bone. This is a thick tendon here. Wow, let me get this one. This is really interesting. Okay, look how big this tendon is for this little bird here. Like, look at that. That's a... And so, okay, and so deep in here, you can see the other deeper layers of fascia. And you can also, yes, now you can probably see the striations in this darker piece of meat here. See the striations in that? And here too? Okay, so that's how you can tell the direction of a muscle, which is very important, because once you can tell the direction of the muscle, you can tell which muscle, at least in a human, that you're working on, or, yeah, or that you're feeling, that you're looking at. This is, look how tough this tendon is. It doesn't even want to bend. There we go. No, see, it won't. That's tough. Anyway, that's... see, these tendons will not let me, the muscle is tearing before the tendons come off the bone. So that's how tough a tendon is. And of course there's more blood vessel in you know, in there inside the bone. And so yeah, so that's tendon and muscle and fascia, how it interacts with in a creature, okay, that used to be alive. My hands are disgustingly dirty now. I'm not going to be a guy like I usually would and wipe something on my shirt. I'm actually going to go wash my hands, and I'll be right back again. So hopefully now you have a better understanding of muscle and how muscle interacts with both tendon and fascia, and what the different types of fascia are. The epimysium, the paramysium, and the endomysium. We went over a quick demonstration of an avulsion fracture when the tendon pulls the periosteum off of the bone or partially out of the bone. Now ligaments. Ligaments, they connect bones together at a joint. They strengthen and stabilize joints, and they can cross either one joint or multiple joints. So a ligament that crosses one joint would be like a tendon in the knee, and one for multiple joints would be like something called your anterior longitudinal ligament, an ALL for short, okay? All, meaning all vertebrae, all right? In the front, anterior longitudinal ligament. So that ligament goes all along all the front of these vertebrae. And you also have one called the PLL for short, the posterior longitudinal ligament. And I will actually show you a picture. Again, we're going to go back to the Atlas of Human Anatomy, 4th edition, the anterior longitudinal ligament. So here is an image of the spine. Actually, it's just the lumbar spine and the sacrum and coccyx, or coccyx, depending who you are. So this would be the anterior portion of the spine. This is the posterior portion of the spine. Here's the spinous processes coming off the back. Okay, this here is the ligament. That's the anterior longitudinal ligament. Now it actually goes up all the entire length of the spine. This is just the lumbar spine. And, oops. Book is falling apart because I use it so much, but only so much. So that's ligaments. Retinaculum. A retinaculum is a structure that holds an organ or tissue in place. It's a transverse, there's a word from lesson number 1, a transverse thickening of deep fascia which straps the tendons down in a particular location and position. One of the ones you might be familiar with is the flexor retinaculum. It's also known as the transverse carpal ligament. It's part of the carpal tunnel. You've heard of carpal tunnel syndrome. Okay, well, the carpal tunnel is right here. And so the flexor retinaculum crosses from here to here, and you've got some tendons that go through there, and along with the median nerve. And I think I have a picture of that here as well. The flexor retinaculum, transverse carpal ligament. All right. So here we go. Forearm and hand, and that would be it right across there. Coming through here are the tendons, and that little white one there is actually the median nerve. Can you see that well enough? Flexor retinaculum, tendons, nerve. And retinaculum comes from the Latin verb retinere, meaning to retain. And lastly, we have interosseous membrane. Interosseous membrane is a fibrous tissue that binds the radius to the ulna, okay? The radius and the ulna, and it binds them so that they don't separate or something like that. It can also be an attachment site for some muscles, and it will divide the forearm into anterior and posterior compartments. We saw the different compartments on that, turkey drumstick. And you also have one in your lower leg between your tibia and fibula, which is called the middle tibiofibular ligament. And I will actually show you a picture of that. I think I have one. Interosseous membrane. Okay, so I have a couple. Here's the one for the forearm. Okay, the interosseous membrane of the forearm. Right in there. The white stuff goes back and forth. That kind of a thing. And lastly, mail call. The one between the tibia and fibula, the middle tibiofibular ligament. All right, and it's right here. It's on an angle. And it does the same thing. It divides the different compartments. You've heard of a compartment syndrome, anterior compartment syndrome, etc., posterior compartment syndrome. Well, that is what divides the compartments. It's one of the things that divides the compartments. And that is lesson number 3. I hope you enjoyed it. I hope you learned something. Coming up in the next few lessons, we are going to be getting into muscles a little more. We're going to get into naming of muscles. We're going to get into bones and bony landmarks, because that's very important in identifying muscles. All these, the 3 things I'm talking about now, bones, names of bones, bony landmarks, and naming of muscle names. Very important in identifying what the muscle does. Some muscles are named for what they do, where they are, etc. So we'll get into that in the lessons. In the meantime, thank you for joining myself and my Zorro-looking pal here, Sparky. And hopefully we'll see you next time, or at least you'll see us. Zorro. You don't even have a sword. Or a whip. See you next time.